So we have completed the topic recursion. I have explained you its working. I have explained you the steps involved in execution of a program. And the important thing was activation records. And also you have seen the tracing tree. You have seen how to trace a recursion. And you have also learned how to analyze the time complexity also. Okay. So now my job is over. Your work starts now. Your job starts now. So I'll be writing the question, right? Some gate questions we'll do. So that the questions I am giving it based on my own flow. So you'll not find the questions in the same order in the question bank. Okay, they will spread across different places. So I'll be showing them so that step by step you will also grasp the topic thoroughly. Okay. So now the thing is, I'll write a question. I'll give you time. You have to solve it. When I say answer, then only you should answer it. Right? Because some may be doing it fast in some question, some may be taking time, right? In some other question, that same person may be faster. So anyway, so whenever I say answer it, then only you should answer. Don't give quick answer. Otherwise, it will confuse all others. And make sure everybody is solving it. Okay, don't wait for others to answer it. Because this is what you have to practice. It's like coaching, right? So you have to practice, then only you learn it. So let us start. Uh, oh, sorry. Oh, what has happened? Int function f, which takes parameters n, right? And it is having a static variable. You are familiar with the static variable, and you also know what to do when you are tracing a static variable. Its initial value is 1. And there is a condition. If n is greater than or equal to 5, then you should return n. So in the same line, it is written. Then n assign n plus I plus plus. Then return f of n. Okay. Then you have to find out what is the result of the function call f of 1. Just listen. Listen, let us read it. It is having a static variable. So you should know that you should declare it separately and keep on changing whenever the values change. Then next, inside if, how many statements are there? Inside if, only one, that is return. That is return. If this condition is false, then these statements will execute and it will return the result of this function call. So it's a recursion. And also static variable is there. So last class we have seen static variable as well as recursion. So I'm sure everybody can give answer. So when I say answer it, then only you answer it. f of 1. This is having a static variable I. You can make it as 1. Then is it greater than equal to 5? No. Then one step is n assign n plus I. So what is the value of n? 1. 1 plus 1, that is 2. N becomes 2. And I plus plus, so actually this I plus plus will modify this one. So you can write down this statement and make a change there. And then I'm not writing 2 here, so you can write 2 also, no problem. Then next statement is it is going to call f of n. So what is the value of n? N is 2. Then again, if n is 2, 2 is not greater than or equal to 5, then there are 3 steps in this one. So this is n plus I, that is 2 plus 2. How much it is? 4. Then I plus plus. So this will make it as 3. Then it will call f of n. Hmm. Sorry, f of n, sorry, 4. F of 4. So for 4, n is equals to what? N plus I. So 4 plus 3, that's going to be 7. Then I plus plus I is going to be 4. Then call f of 7. F of 7 this time, n is greater than or equal to 5. Yeah, 7. So it's 7. So answer is what? Returns 7. So the result of this function is 7. The result of this function is 7. This is 7. And this is returned to here, same value, 7. And this will also return the same value, that is 7. So because it is returned, whatever the result of the function is returned. So again return, and the answer is how much? 7. All of you got this one? So this was the first program, so I have traced it. So it was simple one. All of you got this one, right? If anybody doesn't get the answer, you have done something wrong, just raise your hand. I'll come and check it. I'll come and check it. Okay, don't hesitate, don't feel shy. Because so you may or may not get the answer. Okay. So it doesn't mean that somebody got the answer you are unable to do. So don't feel shy about that one. All of you have done it. All of you have done tracing. Okay. Next. Yeah. Online. Yeah. Yes. Deepak has given the answer. Yes, correct. At 7. Now the next question. It's a similar one. Means it's a static variable is involved here again. Int. These are gate questions. I'll use yellow once again for writing the question. Int f parameter is n. Static. See, even when I was explaining, I was writing the name like fun f. So because in gate question also they use the same type of names. N is less than equal to 0, then return 1. If it is less than equal to 0, then return 1. If means else, if it is not less than equal to 0, then check if is it greater than 3. If it is greater than 3, return n is sorry, assign r is equals to n, r assigned with n, then return f of n minus 2 plus 2. Else, even if it is not greater than 3, otherwise, then do what? Then return f of n minus 1 plus r. That's all end of the function. And you have to find out what is the result of this function when it is f of 5. Now one thing, the value of r, you should add it at returning time. Returning time, better. Okay. So whether it's changing or not, it may change at the end also. So add it at the r. Just one hint I have given you. Now when I say answer, then only you should answer it. So I'll wait for you to complete it. And everybody should answer it. Those who are watching online, they should also solve it. And don't answer the question unless I say answer it. It will discourage others and confuse others. Ah, what is the answer? 18. Shall I trace it? Shall I trace it? Okay. Quickly, I will do. See, f of 5, f of 5. This is having a static variable r, so let us keep it separately as a global variable outside the function call. In every call, you don't take a new variable. N is less than equal to 0? No, it's not less than equal to 0. Is it greater than 3? Yes, it is greater than 3. So the first line is r assign n. So whatever the value of n is, that should be stored in r. So r becomes what? 5. The next line is return fun of f of 5 minus 2, that is 3 plus 2. 3 plus 2. All right. Then now the 3 is called. 3 is not less than equal to 0. 3 is not greater than 0. Then this is the call it is going to make. So that is what f of 2 plus whatever the value of r is. We will take at the end. Okay. Now we know that is 5 and it's not changing, but make it as a practice for the static variable, global variable. You take them at return time only. So that will be better. Then now 2. 2 is not less than equal to 0, and this is the 1. So f of 1 plus something. So now 1 is not less than 0, not greater than 3. So one more time call is done. So f of 0 plus whatever r is. Then f of 0, yeah, less than equal to 0. Yes, it is 0. So the result of this function is 1. So this is 1 plus what is the value of r right now? 5. So this becomes how much? 6. So the result of this one is 6. 6 plus what? 5. This is how much? 11. Then this is 11 plus 5. R is 5 only. So this is 16. Then this is 16 plus this was not r. This was 2. So this is how much? 18. So the result of this function is how much? 18. All right. You want to take that? I'll just keep it for a while. See, next question, you must trace it. Every question you must trace it. No, static variable will not be declared every time. It is created at loading time and remains, yes, it created only one time only, yes. Yeah, most of you have given the correct answer. Very good, very good. Is it okay? Now, this is a next program. Oh, sorry. Void count integer n. Then this is also having a static variable, and the value the variable is d and its value is 1. Then it's having the code that is printf percentile d and print the value of n, and then print the value of d also, percentile d. That is a static variable. It's taking printing the parameter as well as d. Then it will increment the value of d. So the static variable value is incremented. And then if n is greater than 1, count is called itself for n minus 1. So in the same line it is written. Then finally, print percentile d, the value of d. And that's all. Then from the main function, I'm not writing the main function. I'm saying just what will be printed if you call count 3. What is the output? You have to show the output. N is printed, D is printed, D is modified. And if N is greater than 0, again the recursive call is done. And at the end, again printing of D is done. So what will be the output when you call count 3? Everybody should trace and get the correct answer. When I say answer, then only you answer it. In online also, answer when I say answer the question. Hmm. Printf D is there. That is at the end. It's at the returning time. So print only at the returning time. So because the value of D is keep on changing. So what's your answer? 3, 1, 3, 1, double 2, 1. Okay, 1, double 3, double 3, double 3, double 3. Option A. Another answer? 3, 1, double 2, 1, 3, triple 4. Option B. Option C. 3, 1, double 2, 3. Okay, enough. So, no. Answer is one among these. See, you gave the answers, I have written them as options. So it means when you solve gate question, somebody may be getting this answer, somebody may be getting this answer, right? So now which one is correct? B. Because the final value of D is finally when you say D++ and when you call again once again, so it will not execute, so it will start printing. So it will print 4, 4, 4, 4. In the last call, D becomes plus plus, D becomes 4. Yes, how many of you got fourth one? Sorry, B. Okay, very good. Now, those who did not get, check the code once again, check the tracing part once again. Or if you say, I will trace it. Ah, see, for tracing, you may be getting wrong answer while tracing. But for understanding the question, are you facing any difficulty? Code-wise, reading the code and all? No, you are able to do it anyway. Because I want to know whether you are comfortable with the syntax or not. Output you are getting wrong, that's okay. Because that needs practice. That needs little more concentration and observation. So shall I trace or shall we go ahead? Okay. I am calling this count for value 3, and this is having a variable d whose value is right now 1. Then print n and print d. So print n, that is 3, print d is what? 1. Then d plus plus d becomes 2. Then if n is greater than 1, yes, n is greater than 1. Call count once again. So these are the steps. See, 1, 2, 3. D plus plus directly have done. So 1, 2, 3, third step directly have done. Fourth condition is there. Then one more step is there. So it has to call count for what? 2. And also one more time it has to do printing, but that has to be done at returning time. So if you see the steps, 1, 2, 3, and 4. So this is step you can directly do it, D++. I'm not writing it there. Okay. Then 3 and 1 are over. For 2, 2, so it will print the value of 2, and this it will print this value 2 because D is 2. Then after that, D++, D becomes 3. Then n is greater than 0. Yes, it will call count for 2 minus 1, that is 1. And one more printing it has to do that it will do at the returning time. Now for 1, it will print what? N value 1, and the value of D is what? 3. And after that, D becomes what? 4. D becomes 4, D plus plus. Then N is greater than 1. Yes, N is greater than 1. So it will call C of 0. Then after that, it has to print one more statement at returning time. Oh, sorry. N is greater than? Yeah. N is greater than 1, then all it has to do. Otherwise, it doesn't do this statement. It doesn't do this statement. And if it is not doing this, is there any return after this one? No. So will it execute this one or not? Yeah. Call is not done, but will it execute that statement? Yes, 4. So right now D is what? 4. Then after that, go back in the previous call. Again, it has to do printing once again. So it will make print 4. It will go back. And what is the value of D right now? 4. So answer is what? 3, 1, 2, 2, 1, 3, 4, 4, 4, 3 times. Here the call was not done. And here return is not there. Return means it will stop. It will not execute the next line. It will go back. So just it will skip that line and print 4. So this was not done, and 444 is printed. Same tracing tree you got. Check where you have missed. If you did not get the answer, check where you have missed. I think you have not made it 4. You kept it 3 only, and you. So because D++ will be done here. So D++, D++ is happening here. D++. Now let us move on to the next. Now one more printing one. One more printing related. I'll give you, yeah, here. Void fun 1. No, this is a recursive. So let us do it afterwards. Indirect recursion, sorry. This is indirect recursion. Let us do one more simpler one. Void f integer n. If n is less than or equal to 1, printf percentile d n. Then else f of n by 2 printf percentile d. This is an easier one. And finally, you have to see it is having printf. So you have to find out what it will print for value 173. For value 173, what will be the output? Yeah. So most of you have given correct answer, but some have not given. Hope you have understood. Acha. Mahan Mohanta. Is it your first class? Mahan Mohanta. Is it your first class? If it is first class, then it's difficult for you to follow. Second means yesterday you have attended. Maybe you have missed yesterday's class. If you have, because we covered recursion in the yesterday's class. Rec- uh, huh. Flow division. N by 2, and let me read the code once again. Yeah, n by 2 and n mod 2. This is mod. Mod means remainder. Okay, if you are not aware of this code, let me tell you n divided by 2. So this is the integer division. Integer division, no point something, right? And mod means it will give you a remainder. Mod gives a remainder. So if you divide 173 divided by 2, remainder is 1. Remainder is 1. So remainder mod gives you 1. When I say answer, then only you should answer it. One hint is it will print zeros and ones. Huh. Are you ready with the answer? What's the answer? 10101101. Correct. Yeah, binary form of that number. Binary form of that number. If you say this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. This is 1 plus 2, 1 plus 4 plus 8 plus 32 plus 128. If you add all this, this is 173. So f of 173, then here, if you see what it will do, if n is less than or equal to 1, no. So if it is equal to 1, when it reaches 1, just it will print whatever the value of n is. Otherwise, it is doing only two steps, calling itself, then later on printing. Calling itself and later on printing, right? So calling itself what? N divided by 2. So this is how much? 86, right? 86. It will call itself, but it will divide it by 2. And also it will print n by 2, n mod 2 at returning time. So we'll do it at returning time only. So that's better. Then again, so this is not less than or equal to 1, so it will call itself again. So this is how much? 43, and then mod it will do later. Then it will call itself by 21, and printing will be done later. Only two steps are there. So this is how much? 10, and mod of printing of this mod is done later on. Then this is 5, and printing is done later on. And this is 2, and printing is done later on. F of 1, printing is done later on. For f of 1, what is the value printed? For f of 1, print 1. Print 1. And when you come here, mod of 2 is how much? 0. And this mod of 5 mod 2, sorry, 5 mod 2 is how much? 1. 10 mod 2 is 0. Remainder is what? 1. When you divide this, and the remainder is what? 1. When you divide this by 2, remainder is nothing, 0, because it's an even number, and the remainder is 1. If you see the values 1, 0, 1 0, then 1 0, 1 1 0 1, 1 1 0 1. So this is what the result is. So I have traced it. Uh, yeah. Next question I am writing. See, I will write on the question as well as I will write on the options. See, these are gate questions only. I was not showing you options so that you directly get the answer by yourself. Now, sometimes you can save your time by looking at the options. All right. So in this question, if options are there, you can directly quickly reach on the answer. All right. You can quickly get the idea what the answer could be. So because if you try to trace it, it will go lengthy. All right. So that's why I'm writing the question as well as the options here. Void fun1. So this is indirect recursion. Fun1. If n is equal to 0, don't do anything, just stop the function, return. Otherwise, printf percentile d and print n, and call fun2 function by passing n minus 2. And after that, again, printf percentile d value of n. So 2 times value of n is printed, and in between fun of 2, some other function is called. And what is that other function? Void fun2, I'm writing here, fun2, integer n. See, it is 0, do nothing. Otherwise, print n, call this print n. So 2 times it will print the same value, right? 2 times. But in between, it will call this, so something happens in between. So f of n, okay. If n is equals to 0, do nothing, just return. And here also, printf percentile d n, and call function 1, fun1, by passing plus plus n, means increment the value of n and call it. Then again, printf percentile d by passing n. Now, here you have to find out what it will print if you're calling fun1 of 5. If you pass 5 to the first function. Let me read it once. Then you can copy it. Just wait a minute. See, we are calling function fun1, and it is printing something and also calling fun2. Fun2, if you observe, it is printing and also calling fun1. So fun1 calling fun2, fun2 calling fun1, fun1 calling fun2. So this is what? Indirect recursion. Yesterday, I have just shown you the skeleton, and I said that you will get some gate questions. Then only will solve them. So this is an example gate question. All right. Now, what are the options? Okay, you copy it first, read it, copy it. Then I'll write on the options. So maybe you will be answer it quickly. Without even tracing, you may be able to answer it. Okay. Write it and read the code once and be ready so that if I show you options, even without tracing, you may be able to answer it. No, no, don't tell the answer. Don't tell the answer. No, wait, wait. Are you telling the answer? You have copied it, right? You have copied it. Okay, wait. Don't trace it. Don't trace it. Don't trace. See, I was telling you just copy it, read it, and be ready. I'll give you the option. Maybe you can answer it without tracing. See, first, fun one is called. Fun one is printing n, printing n. Same value it is printing. Same thing it is printing. And in between, some indirect recursion is happening. At what stage, at what level, at how much deep it will happen, we don't know. Now come back to this one. This is printing n and calling fun one by incrementing the value of n. Then later on printing n. So whether this n or this n remains same or different? This n remain same or different? Different, because when it is calling f1, it is changing the value of n. So next time when it come back and for printing, so the value of n will be increased. You agree with this one or not? Understood this one? Understood this one? Now I'm writing options. You have to tell me which option is correct. First option A is what? 5 3 4 2 3 1 2 2 2 3 3 4 4 5. This is option A. Option B is 5 3 4 2 3 1 2 0 1 1 2 2 3 3. B can be an answer. So you know this, right? So option C is what? 5 3 4 2 3 1 2 0 2 1 3 2 4 3. No, actually it is D. I have written it first to get no from you. Okay, so when you see question bank, it will be D. So I am writing next one option: 5 3 4 2 3 1 2 2 1 3 2 4 3 5. What could be the possible answers? A and D. Among that, which is the correct answer? D or A? Print n, increase n, and print n once again. Print n once again. Increase n and then print again. I already told you, highlighted this, that it is increasing the value of n for calling that one. See, plus plus n means the value of n itself changes. It is not n plus 1. It is not n plus 1. And if suppose 4, so it will become 5. And if it is 3, then it will become 4. But n plus plus means whatever the value of n is, suppose it is 3, so it itself will become 4. So next time when it come back, value of n is what? Increased. Suppose this was 3, this is 4. Suppose this is 2, this is 3. All right. That's the point I highlighted. Now you said that these could be the possible answers because you know that it's printing same thing twice. So 5, 5, 5, 5. 5, 3, 5, 3 cannot be the answer. In between, what is happening, we don't bother. Right? Now, if you see the second function, the second printing is done by this function. So n plus plus n. N plus plus n. So this value and that n value, there should be a difference of 1. So this is 3, this is 4. So the correct answer is what? A. Correct answer is A. Now, if you trace it, it will be a little lengthy, but you get the same answer. So here, see, one thing. In GATE, they have given this question and so much lengthy output is there. So do you think they want you to take so much time and solve and give the answer? So when such a lengthy answer is there, means there must be some trick that you can solve it fast. So in that, when you look at the options, 2 options are gone already. Now only 2 options you have to verify. Verify. So the first one is correct. Is it okay? All of you got it? Yes, correct. A, most of you have answered it online. Yes, your answer is correct. See, when I am looking this side means I am answering to online students. Okay. So screen is on this side. Are you comfortable with this? Without tracing, we have done it. All of you are comfortable? Huh. Because there are many such questions without tracing or without solving entire thing, you can directly give the answer. So whenever answer is lengthy, try to, there is a hint that it can be done faster without solving everything. Okay. Chalo, next one. Uh, yeah, I've given this question. Now, this one, see, that was two printing functions I have given you. Both are get questions only. It means they ask the questions with recursion and printing. You agree with this? So again, there may be a question in future with recursion and printing. Possible or not? Yes. Two or three questions are there. So two already have shown you. Now, again, this type of questions are common in GATE. So I'm writing the function. Unsigned int. So it's integer only, but it will not take negative values. Foo is the function name. Unsigned int n. Whenever you feel enough, you tell me, I'll start the topic because we are solving the questions. Here you have to work, right? So return n mod r plus foo n divided by r, comma r. This entire result will be returned. Mod value plus the result of this function. So mod value you can take later. First you should get this result, then you can add with mod value. Acha, if n is greater than 0, then do this. Else do what? Else do nothing. Just return 0. And you have to find out what does this function return for 345, comma 10. What is the result of this function? You can trace this one. There's a smaller one only. Danish, actually, if you read the code in the previous function, fun of 2 was printing n, then plus plus n. So the value of n will change. If n is 3, it will become 4. And it is calling the function, no doubt. But when it return back, so the value of n remains 4 only. So it will print 4. So if you see the first function, both the time nn is printed. If you see the second function, both the time nn is printed, but in between that n is incremented, plus n. Plus n means value of n changes. Value of n changes to increment by 1. All of you got the answer? What is your answer? 12. 12. Sum of the digits of a number. Actually, it's a decimal number. Take it as a decimal number. Divided by 10. So mod by 10 and divided by 10 every time. Mod by 10 and divide by 10. So it's giving the sum of the decimal digits of a number. Sum of the decimal digits of a number. All right. Now, one thing. If I make it as a 2, then when divided by 10, sum of the decimal digits of a number. Decimal digits are what? 543. That's what you got. Right? If I give it as 2 here, the sum of the binary digits of a number. So first of all, the number will be in the binary form, whatever the binary form is. So you will not get the binary form of a number. You will get the sum of the binary digits of a number. Understood this one? Right? So same function. If you're passing 10, so every time taking mod of 10 and divide by 10. Right? Mod by 10, divide by 10. Mod of 10 means what? 5. Divide by 10 means 34. Okay. So you are getting 5. Next 4. Then 3. So it was sum of the decimal digits of a number. So instead of 10, if you write 2, then same program, what it will give you? Same function, what it will give you? Mod of 2, mod with 2. So what's the remainder with this one? 1. 1. Then divided by 2. So 345 divided by 2 is 172 something. 172. Then that 172 mod is 0. And then divided by 2. So it will be getting what? Binary digits. Binary digits. Binary form, whatever the binary form is, it will get those digits. But it will not print the digits. It will give you the sum of the binary digits. Okay? Understood this one? Now, suppose you have the number 25. So, sorry. You have the number 25. What is the binary form of this 25? Binary form of this 25? 16 plus 16 plus 8. 24 and 8. This is 4 is nothing and this is 1, 0. This is the binary form of this one. Right? So what this function will give you, if you call this foo by passing 25 comma 2, then what's the answer? 1 plus 1 plus 1, 3. It will give you 3. It will add binary digits. 1 plus 1 plus 0 plus 0 plus 1. All right. So answer is, are you getting me? If you call this foo function, same function I am saying, see, you are passing the base also. So you are getting the sum of the decimal digits. If you change the base, you will get the sum of those digits. That's it. Simple form. So it will convert into, it will not convert the entire number into binary form, but in binary form, whatever the digits may be, it will add them and give it to you. Okay. So you can try this program on your machine anyway. So now, next function. Any question from here? Yeah, sum of the binary string. Yes, correct. Now, this is a similar one. Similar one. Int f, integer n, integer k. If n is equals to 0, then return 0. Else, if n is not equal to 0, then check if n mod 2, n mod 2, then return f of n by 2 comma n, sorry, n by 2 comma 2 multiplied by k plus k. This is going to be little lengthy and you should trace it very carefully. And okay, else do what? Just return. I have to explain something in this one. Minus k. Just wait a minute. Just look at here so that you can later, after that, you can copy and start doing it. And finally, you have to find out what it will print for 20 comma 1. 20 comma 1, what it will print. What is the result? What is the result? Okay. Now watch this. Look at this one. See, if n is equals to 0, return 0. It's returning value 0. All right. So when it is 0, you have to return 0. But here, next, else if n mod 2, in condition only n mod 2 is written, means what? If it is equal to 1, it is true. Means if it is odd number, then it is true. It will do this. Else means even number, it will do this. Odd number, do this line. Even number, do this line. Odd number, do this line. Even number, do this line. Okay. Now, one more thing. Value of k is passed as 1 initially. Value of k is passed as 1 initially. Then every time value of k is multiplied by 2. Here also multiplied, here also multiplied, here also multiplied, here. And passed for the next function. But for the current function, whatever the value of k is, that is added and this is subtracted. So now you have understood how the code is written. So if it's odd number, it is performing this line, even number performing same this line. Only the difference is that is plus and this is minus. And this addition and subtraction, when you will do at calling time or returning time? Returning time you will be doing it. So finally you will get some answer. So solve it, and when you are ready, then only when I say answer, then only you answer it. F20 comma 1, and it's not 0. So either this call or this call. So no branches, only one call. So fun n by 2. So that is 10. Uh, n mod 2, 20 mod 2 means 0. So false. So it will go here. N by 2, that is 10, comma 2 into k. K value is 1. So this becomes 2 into 1, that is 2. And minus k, that is 1. Right now it is 1. So anyway, you can do it at returning time, but it's not a static variable. So if you want, you can write 1 right now also. Then for this one, again, mod 2 is 0 only. Mod 2 is 0 only. Then it will call this one. So the next one again by 2, that is 5. And this time 2 into whatever the value of k is, so that is 4. Then the minus whatever the value of k is. Right now, actually, it is 2. We are passing it for the next function as 4. So this is 2. So this value you should subtract. That is true. So that value you should subtract. Now this time 5 mod 2, remainder is 1. So this call. So this call is similar only. So that is 5 by 2 is 2. Then whatever the value of k, we have to call this function by multiplying it by 2. So this is going to be 8. And also you should add whatever the value of k is 4. But we have to finish this call, then only you can add this one. So this one, again, this is an even number. So it will go here, not an odd number. So this is 1. And then this is going to be 2 into 8, 16. And this is going to subtract 8 from this one. Subtract 8. Now this time it is odd number. So odd number means what? F of n by 2 is going to be 0, and this is going to be 32, and plus k value is what? From here it is 16. So this is 16. Now for this call, so 32, n is what? 0. N is what? 0. 0 means the result is how much? 0. So result is 0 means what now? The result of this one is 0. 0 plus 16. Now you can do addition. So this is 16. So this is 16 minus 8 is how much? 8. And this is 8 plus 4 is how much? 12. And this is 12 minus 2 is how much? 10. And this is 10 minus 1 is how much? 9. And the result of this function is 9. Yes, correct. So it's only based on recursion, no pointers, no arrays, no strings, nothing. Just printing and sometimes static variable is there. What all we have studied yesterday, based on that only, I have selected only those gate questions. Okay. Again, when we learn about pointers, again, there are some normal question, again, along with the recursion also questions are there. So I have more questions. Shall I continue? Now, this is a little tricky question. Just watch it. Watch it. When I am writing, you watch it. Don't start copying. Watch it. Read it along with me. Void convert function is there. Sorry. Convert function is there, which is taking a parameter n. Okay. If n is less than 0, if n is less than 0, then printf percentile d n. Else, else in bracket, convert n divided by 2, n divided by 2. Then also printf percentile do d and n mod 2 over over. This is the code. Now, what value you should pass to this function and what will be the result, I'll show later. Okay, I'll show later. But first of all, you read the code. You read the code. What it is doing, if n is less than 0, then print n. So which is the termination condition of this recursion? N less than 0. N less than 0. Very good. Otherwise, if it's not less than 0, divide n by 2. Divide n by 2. Then at returning time, you print the mod of 2. Mod of 2 means what? Which type of number you will get? Or 0 or 1 means binary number. It is going to print binary number. If you quickly see this one, it's going to print binary number. Right? 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 Correct? Correct? So just now I have shown you one with decimal and I said that just you make it 2, it will print binary. So it will give the sum of the digits of binary, but now it will print. It will print. Now I'm writing this. I will pass 25. Okay, wait a minute, wait a minute. You don't have to answer it. Do you find any problem with the function? Just read it and just keep it with you. Keep it with you. Don't answer it. All right. Do you find any problem with the question code? Problem in the code? Okay. Just keep it with you. Don't tell me. Okay. See, little bit hint. Those who could not find it, little bit hint. N is 25. Divide by 2. How much? 12. Divide by 2. 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 When it will become less than 0? Less than 0, it will never become. Last value is what? 0. Not less than 0. So that termination condition, will it ever reach? No, the condition is wrong. Condition is wrong. Okay, it should be less than or equal to 0, then only it will stop. Otherwise, never less than 0. So 0 divided by 2, 0 divided by 2, 0 divided. So what is the effect final result? Very good. Very good. Very good. This what the answer is. So I'll read out the options. I'll read out the options. The question is, he has not given anything and asked you to print, show what it will print. So which one of the following will happen when the function convert is called with any positive n as an argument, any value of n passed? So the options are, it will print the binary representation of n in the reverse order and terminate. Second option is, it will not print anything and it will not terminate. It will not print anything and it will not terminate. And it will print the binary representation of n and terminate. And it will print the binary representation of n but will not terminate. So what is the answer? It will not print anything and it will not terminate. It will not print at all because printing is done at returning time. So it simply keep on calling and never reaches this condition also. So it will not print this one also. So it will not print and never terminate. Answer is this one. So these are the four different options. So if I show you, uh, this is the one. Oh, I should say select and zoom, right? This is the code that I have written, and these are the options. Which one of the following will happen when the function convert is called on the positive? So any one of these options. So now with this, looking at this option, you can relax and say that you don't have to trace and get the answer. Just you have to read the code thoroughly and answer it. So some questions are like this also. Okay, they will not ask you always output, but here it will never terminate and not print anything. So option is B. It will not print anything and will not terminate. So otherwise, one more option can be there. This will cause a stack overflow. That is also true. Stack overflow. Recursion is not terminating means what? It will cause stack overflow. Some other type. See, again, this type. This is one of the point. Question point, I will call it as question point. On the same point, they have asked one more question in which the option is stack overflow is there. They give the question and say what will happen. So stack overflow happens. So they want to make you make confirm that do you really know how recursion works or not? So is it terminating or not? You are able to read it or not? So upon that also they frame the questions. Now next. Yeah. I am writing the question. You don't have to struggle much upon this question. You can quickly answer it without tracing much. Without tracing much. Okay. The question is lengthy, little bit lengthy. Oh, int foo, integer x, integer y, integer q. Three parameters it is taking. And if x is less than or equal to 0, as well as uh, y is less than or equal to 0. If both are less than or equal to 0, then return whatever the value of q is. Whatever the value of q is. If reading the question is very important here, x is less than equal to 0, then return foo of x comma y minus q comma q. And if y is less than or equal to 0, then return foo of x minus q comma y comma q. And finally, if none of these conditions are true, then return foo x comma y minus q comma q plus foo of x minus q comma y comma q. And you have to find out what will be the result of the function when you pass 15 comma 15 comma 10? When you call the function by passing 15 15 10, what will be the result? Just look at this one. This is from 2021, I think. Look at this. Wait a minute. If both are 0, return q. What's the value of q? 10. Is it changing? Q is changing anywhere in the entire function? So always q is 10 only. So now you keep in mind q is 10. Okay. Then next thing. Both are 0, then it will return 10. Simple. Now you can remember this. If both are 0, return 10. Achha, if x is less than or equal to 0, x is 0 but not y. But not y. Then what it is doing with y? Whatever the value of y is, from that it is subtracting 10, subtracting 10. Maybe repeatedly it is doing. So it is trying to forcefully bring it on less than or equal to 0. Less than or equal to 0. And in this, when y is not y is less than or equal to 0, but not x, then it is trying to subtract q from there, q from there. So until so that it's forcing that x to become 0. Y is already 0, you also become 0. So in this return q is there, 10. In this, whatever the result of the function return, nothing, no operations are done here, no addition, subtraction. Here also, whatever the result is, just return. But here, these two results are added and returned. So the important lines are this one and this one. So if not this one is, none of them is less than or equal to 0, then it will do what? One time it will reduce q, one time it will reduce x. Okay. So little bit of tracing, you can tell the answer. You don't have to draw a very big tree. Draw it carefully. Little bit of tracing. Okay, I got the answer. You can tell the answer. Yeah, Mohanta, already I told the options. So I did it little quickly. Option B means function will not terminate and it will not print anything. And that was the answer. So just I wanted to show the printed form of the question. So I have done it. Because already I have written everything on the board. So just based on observation, you can quickly answer it. It's possible. From online, somebody have given the answer, but the answer is correct. First time this statement gets executed. This one plus that one. So from there you can observe and see what may happen. I gave you one hint that it is forcing them to become less than or equal to 0. Finally, when they are less than or equal to 0, it will return 10. So whichever direction you go, you'll be getting 10 from there. If anybody got the answer 40, that is wrong. Don't tell the answer. Some are still solving. Let us give time. Because coaching means they should do inside in the class itself. f of 15, 15. I know q is 10, so I will not pass every time. I will not write 10. Okay. So none of them is less than or equal to 0. So two calls are there. In that, addition is done. Addition is done. One is what? Y is subtracted. So this is 15 and this will become 5. And on this side, x is subtracted. So this is 5 and this will remain 15. And q is 10, 10 only. So if you pick up this one, then in this, none of them is equal to 0. So again, there are two calls in this one plus. So here, f of first one, x remains as it is, but y becomes minus 5. And here, f of x becomes 10, sorry, x becomes 5, sorry, 5, and y remains 5. Y still remains 5. Now, if you see this 15, 5, so you can see that y is less than or equal to 0. So what this call will do, keep on subtracting q from x, and finally both will become 0. So the if I without tracing, I can say that the answer of this function is what? 10. If you trace also, finally 10, 10, 10 will come back. Okay. Now on this side, if you see, both are not equal to 0. So what it will do now? So first it will call what? With yeah, x as it is 5 and y is minus 5, plus on this side x is minus 5, y as it is. No, one of them is 0. Definitely from here it will become 10. And one of them 0, it will force them into 10. So this is 10 plus 10. How much? This is 20. So the result goes here as 20. And this is a 10 plus 20. So this is how much? 30. So if you see the other side, this was 15, 5. So this is 515. Mirror image of this one. So if you expand this also, this is going to be 30. So 30 plus 30 is how much? 60. So that's what I told you, that without tracing much also, based on the observation, you can answer it. Otherwise, if you want to spend time, you can do it. But the question is designed so that you can trickily answer it quickly and your answer will be correct. Answer will be correct. All right. Because if you go on expanding it, the code is very lengthy. So if you go on expanding it, you may get a very big tree. So in short, you can give the answer. All right. 60, all of you got it? Any problem in this one? Have you got this one? Sure. Now, one more similar function. Int sum function. Function name is sum function, which takes x and which takes y. And if x is equals to 1 or sorry, or y is equals to 1, means if any one of them is 1, then do what? Return 1. Then if x is equals to y, means both are equal, then do what? Return x, whatever the value of x is. Equal means you can return y also, x also, is same thing only. Acha. If they are not equal, then x is greater than y. Then do what? Return the result of this function. What? Sum function. And to that, from the value of x, subtract y and y as it is. If y is greater than x, then return sum function, and x you pass as it is, but from y you subtract x. Okay? Then, if you're calling this sum function by passing See, the previous one and this one both are numerical type question. Numerical type question. So you have a blank, you have to answer it. So that was 60, correct? And this one also you can answer it. And this also you can answer it trickily if you read the code and understand it. So first you should spend some time, little bit time for reading and understanding the code. It is similar to the previous one where without much working you can answer it. So here also without much working you can answer it. 15 and 255 is passed, yes. Shall I give you hints? If you have finished writing, I'll give you hints. See, initially this is 15 and this is 255. And at some time, maybe they become, any one of them become 1. We don't know. We don't know. And also there is a possibility that they both become equal. If they both become equal, the answer is X. If any one of them is 1, then the answer is 1. So sure shot, there are only two possible answers. Either it is 1 or it is X. Right? X. Now, X is greater than Y or Y is greater than X. So in the values that we are passing here, Y is greater than X. So from Y, every time, so it's too much larger, right? Y is too much larger. From that, X is subtracted, again subtracted, again. So it will be recursively subtracting, subtracting, subtracting. So 15 will be keep on subtracting from this one. So if you keep on subtracting, now two things may happen. At one stage, either X may become greater than Y or Y may become less than X, or they may become equal, or any one of them should become equal to 1. Any one of these things should happen. So what is the more possible thing? Equal, equal. They may become equal. So at what value they may become equal? Very good. You got the answer. Very good. So every function, you don't have to trace it. You can read and understand the things and you can answer them. All right. 17 times. It gets 17 times. So 16 times it will subtract, and the last remainder is 15 only. Both are equal. It will get exactly divisible by 15 for 17 times. 17 times. Exactly divisible. No remainder. Means at one stage they can become equal. If there is a remainder, means that either this one or that one will become 1. Possible 1 if the remainder is 1. So they will become equal. So this is the answer. Understood? All of you got it? Yes, without tracing, you have answered it. So now what is more important? Just look at the question, start tracing, or read and understand the question first. Read and understand the question first, then you may be giving the answer quickly. Okay. Or else when you read it, if you are tracing also, you have to trace it, then only answer, then also you can have everything in your mind, then you can do it easily. Otherwise, first line, then second line, third line, every time don't trace the line by line, don't trace it. Okay. So try to read it and understand. So have it in mind, then you start tracing. So this is over. Uh, yeah, already I have given this function. Sorry. Uh, yes, 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 yes. This function. This is little tricky. It is trying to take away your concentration to other place and asking a question upon something else. Again, reading, tracing is required here, but thoroughly reading is more important, or perfectly tracing it is more important. Int counter assigns 0. Counter is a global variable. And int CALC A and B. Yeah, all of you got the answer 15. That's great. You are doing it, solving it. That's perfect. Calc is a function name. Inside this, a variable c is declared and counter is incremented. Counter, that is a global variable, is incremented. Then after that, if b is equal to 3, then do what? Return a into a. So whatever the a of value of a is, that should be cubed and return cube value of that. Else, C assign calc of a comma b divided by 3. And after that, return whatever the c value you have, you return the cube value of c. Then this is the end of the function. Then here, uh, in the main function, I'm writing the main function for the first time. So you should understand there must be something important here. Call 4 comma 81. Call 4 comma 81. 4 comma 81. Then printf percentile d counter. And this is a numeric type question. And it's asking what is the output of this code? What is the output? You have to trace it, then only you can answer it. I have changed the batteries in mic, so there was no voice for little while. Can you hear me? Yeah. Yes, Adrija, your answer is correct. Sangeeta and Vinay, yes, your answers are correct. Somebody has given wrong answer. Danish, you check it once again. Yeah. What is the answer? Very good. Answer is 4. See, you don't have to trace the function completely. The moment you see that it has to go on returning, now you can stop there, because finally you have to print the value of the global variable. So how many times it has got incremented? 4 times it has got incremented. That's it. Right? So without tracing the entire thing, you can answer it. If you trace also, there is no use of the result of what it is returning, because we are printing counter. So read the code thoroughly what he is asking. Okay. So next gate question. So this is the familiar one. You have already seen it and you know the answer. You can quickly tell the answer. This is a gate question once again. So already you have seen similar gate question. I'm writing it. Unsigned foo, unsigned int n, unsigned int r. If n is greater than 0, return n mod r plus foo n divided by r comma r, else return 0. What is the result of the function when you pass foo 513 comma 2? Same question, just now we have done it. Sorry, 513 comma 2, 513 comma 2, 513, not 512, 513. Just now you saw the same piece of code. That time we were passing 10. And that time I told you that if you pass 2, it will be some of the, yeah, whatever it was. So binary digits. So now you can understand one more thing, that recursive function with mod and division is a favorite thing for gate questions. So they have repeated the question multiple times. Right? More than one questions are there upon it. Printing part was there, static variable was there, global variable was there, and this is mod and divide. Mod and divide. Multiple questions we have seen based on this one. So in every subject, you have some key points upon which they will ask questions. Otherwise, the question becomes very simple. So what is the answer for 513? 2. Yes, 2. Right? 512 is 1000000, but 13 means one more 1 at the last. So 1 and 1 at the last. So answer is 2. Some of the binary digits of a number. So answer is 2. Yes, perfect. And those who are solved online, yes, they have given the answer. So it's sum of the digits of all that. Adrija has given the answer. So sum of all those digits. Answer is 2. Now, okay. Next question. F integer j static int I equal to 50, int k, some local variable is taken. If I is equals to j, then printf something. If I is equal to j, then print something. Means something should be printed. Then whatever the result of f of I, take the result in k. And finally, return 0. And else return 0. This is the question. This is the code. Now, what is the question? I will not tell you. I will not tell you. Options are given. You don't have to find the answer. Trace and find the answer. Now, just read the code first. Read the code. See, static value of I is static variable I value is what? 50. And if I and j are equal, j is passed, I and j means this I and j both are equal, it will print something and call itself for with same I. With same I it will pass. Right? Anywhere I is incrementing, no change in I, 50 only. Then return 0. Return 0 is there. And here also nothing, just return 0. So what this code is doing? Nothing. So it's trying to print something. When it is printing something, I is equals to j. I equal to j. Acha, if I is not equal to j, it will never print anything. Nothing it will do. Nothing it will do. Right? Nothing it will do. But when it will print that 50, sorry, something, when I is equal to j means both are 50. 50. J is 50. But when it is 50, what happens? Call 50, something, 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 something. Stack overflow. Understood? Understood? Right? So again, you don't have to trace with a tracing tree and answer. Now I am reading out the question. I'm reading out the question and the options here. See, where it is gone. It is moved. Yeah. See, which of one of the following is true? Okay, I'll show this one. I'll show this one. This was the question, and the question is, see, code, this was the code. The question is, which one of the following is true? Which one of the following is true? The function returns 0 for all values of j, including 50 also. No, no, no. So wrong. Function prints the string something for all values of j. No, it will not print for all. Only for 50 it will print. But that too, there is a problem behind it. Then function returns 0 when j is 50. No, no, it will not return 0. It will actually print and keep on calling itself. We saw that. The function will exhaust the runtime stack or run into an infinite loop when j is equal to 50. So exhaust the stack, or also is saying infinite loop. So stack overflow when j is 50. So which of these statements are true? D is true. All right, correct. Understood this one. So online, have you understood this? Yeah, no exit. Actually, it will not reach exit condition. Yes, because the value is always 50. Uh, yeah. Now coming few. Yeah, this is there. Just I am checking if any more questions are. Yeah, there is one more question. This is little difficult. This is from 2020. This is little difficult. Now all difficult questions are there. Right? Little difficult questions are there. Now, sorry. Int fun1. I will be writing two functions. This is a indirect recursion along with static variables. So you have to be careful with the static variables in both the functions. Here there is a static variable int I assign 0. Then if n is greater than 0, then do plus I, means increment that static variable, and then call itself fun1, call itself. by passing n minus 1. And finally, return I. So as long as n is greater than 0, it has to increment I and call itself by reduce value of n, reduce call increment I, reduce n, increment I, reduce n until it becomes what? N becomes 0. Then return I. Guess what this will be doing? If you pass 5, what it will do? Return 5. You pass 4. This is simple, no? You can read it. Huh? If you pass 4, what it will return? Freshly pass 4. 4. 4. Acha, if you first pass 4, 4, again pass 5, then 9. If you call the same function twice, the value of static variable remain as it is previous one. That is enough for you to answer the remaining part of the question. So now this is enough. This hint was enough. I'm writing the remaining part of the question. Integer fun2. Have you understood this point? So, oh, sorry. I'll explain once again. See, I is 0. I plus I means 1, then 2, then 3. How many times? Whatever the value of n is. N is decrementing. Wait, don't copy. So n is decrementing. So it will be keep on incrementing I. So how many times it will increment? Whatever the value of n was. So if you pass n as a 4, answer will be return I, that is 4 only. 4 times I will increment. Now freshly, if you pass 5 to this one, then answer will be 5. Now as it is static, if you pass first time 3, answer is 3. Again you pass 5. So previous 3 is also added to this one because already value of 5 was 3. 3 plus 5 is how much? 8 it will have done. This is enough. Okay. Now let me finish the code. So static int, again this is having a variable I, and this one, if n is greater than 0, then do what? I assign I plus fun1 of n, then call fun2 of n minus 1, and finally return I. And you have to find out what is the answer for fun2 of 5. You have to trace this one carefully, and tracing will give you the answer. Without tracing, you can't get the answer. Trace carefully. You are calling fun2, not fun1. Starting point is fun2, not fun1, right? But fun2 is calling fun1 and also itself. You know what fun1 does? Already I have explained you. Whatever you pass, it will give the same value, but whatever was there already in I, it will add that also and give it to you. So if you call multiple times, you will be getting previous value plus the current value of n. If you got the answer 40, then it is wrong. If you got the answer 70, then it is wrong. So only the important thing is you will be calling this function. So it will take whatever the value of n, same value, plus previous value of I. If you keep that in mind, you can quickly give the answer. Trace and give the answer quickly. If you got the answer, how much? 43 means you stop one step before. 55 means you are correct. 110 means you have gone little beyond. 55 is the correct answer. You got the answer 55? Ah, you are not. Previous one. You are. You should trace. Don't sit idle. 55. Tracing done or not? See, when time is given to you, so everybody should get the trace it and get the answer. Don't sit idle. Don't, because you are looking at the so many examples we have seen. You should be able to trace them. Trace and give the answer. Don't sit idle. Shall I trace it? Fun 2 of 5. So if you see fun 2 of 5, F2 I will say and pass 5, it's having a static variable whose value is value is 0, I is 0, static variable. N is greater than 0? Yes, greater than 0. Then it has to do two things. Otherwise, return whatever the value of I is. Okay. Finally, I value is written. And here also I value is written. So what it is doing if n is greater than 0? So I assign whatever the value of I is plus whatever the value of I is plus fun of what? Fun 1 of? Fun of 5. Fun of 5. All right. And yeah. So fun 1 of 5 that you have to find out now. And that will be added with the present value of I is how much? 0 only. So 0 plus this one. Anyway, I am keeping it. As I said, you should do it at returning time, but I am writing it. So fun 1 of 5. So you have to find out fun of 1 of 5. So what fun of 1 of fun 1 of 5, what it will do? F1 of 5, what it will do? So shall I trace it or directly we should write down the answer? Directly you can write down the answer. It's having a variable I. It's having a variable I that is right now 0. So when you pass 5, this will become how much? 5. And it will return 5. So 0 plus 5, how much it is? 5. This I will become 5. And the next step is it will call itself with 4. N minus 1. Is it till here correct? Perfect. First step is call F1. Whatever its result is, you add it with I and store the result in I. Then call itself with 4. Call itself with 4. Itself means again two steps. What are those? I assign whatever the value of I is plus result of F1 of 4. F1 of 4. F1 of 4. So if you pass 4 this time now, this was 5. 5 plus 4, it will return what? 9. So this is how much? Value of this what? 9. 5 plus 9 is how much? 14. So this become how much? 14. And the second step is it will call itself with 3. If this is okay, then you can write down the rest of the steps. Is it correct? Followed? It has to do two things. See, F2 is calling F1. And F1 is calling itself only. It's not calling F2. And whatever it has done, the result is it's returning here. So if you see F1, if you pass 5, it is passing 5 back. And it is storing 5 in static variable. If you pass 4, then it is returning you 4 back, but added with previous value 5. 9 it will return. All right. So next, if you see F3, what this is, I assign, current value of I is how much? 14, plus what it will return now if you pass 3 to this one? F1 of 3, what it will do? 3 plus previous value of I. What is that? 9. 12. So it will return how much? 12. And sorry, I am doing something wrong here, I think, right? Yeah, yeah, yeah. Wait a minute, wait a minute. Sorry. Start over once again. When you call f2 of 5, it's having I value. That is how much right now? 0. If n is greater than 0, it has to perform two steps. One is I assign current value of I plus f1 of 5. And then it should call itself with f2 of 4. Now, what is the result of this one? So if you see f1 and it is having some variable I whose value is 0, when you pass 5, it will increase the value of that I and make it 5 and return that 5. So this is how much? 0 plus 5 is how much? I is equal to 5 only. So this will become 5. Now this is step. In this again, this is greater than 0. Two steps are there. One is I assign I plus f1 of 4 and also call f2 itself by passing 3. Now, if you observe this, now f1 of 4, so when you pass 4, f1 of 4, so it will increment I by 4 times. So whatever the value of 5 was, I was, in that it will add 4, so total it will be 9, and it will return 9. So if you see, this is 9, and the value of I is how much? 5. 5 plus 9 is how much? 14. So this I becomes how much? 14. Now this call, it's calling itself. In this again, n is greater than 0, two steps are there. One is I assign I plus f of what? F1 of, F1 of 3, and also it should call itself with f of 2. So f1 of 3, what it will do? F1 of 3, so it will add 3 to this value of I. So right now it is 9 plus 3 is how much? 12, and this will return 12. So I'll erase this one. Right now I value is 12 for F1. For F1. It will return 12. And what's the value of I? Right now it is 14. So plus is how much? 26. So this value of I becomes 26. 26. Then it will call itself once again. Again, these are the two steps. I assign I plus F1 of 2, and it will call itself with F1. Right? So when 2 is passed to this function, right now I value is 12. So it will add to this and return. So this will become 14. And the value of I is how much? 26. So this will be how much? 40. So the value of I becomes 40 this time. Then again F1 is called. You have to trace. Okay, just by reading you cannot answer. Trace only and then only you can answer it. So if you have read it thoroughly, then you can trace, then only you can answer it. All right. If you are unable to do it right now, if you got any problem, or if you stuck up anywhere, go home and practice all this. This is very important. All right. Then again, I assign I plus f of f1 of 0. And also it will call, sorry, not f1 of 0, f1 of 1, and call itself with f2 of 0. Now f2 of 0, it doesn't do anything, just return I. And here if you see, I as an f1 of 1. So what is this value of this one right now? This was 14, right? So 14 plus 1 is how much? 15. So this is 15 and that is 40. So I value becomes how much? 55. I value is 55. And here if you see, This will return just the value of I. So what is the value of I here? Right now we have got this one. The value of I is how much? 55. So this will be returning 55. So 55 comes here, 55 comes here, 55 comes here. Just return, do nothing. Return, same value, 55 is return. So the answer for this one is 55. So I already told you in the beginning, this is little difficult question and it is lengthy. And you have to trace this entire thing, then only you can get the answer. Otherwise, if you can figure out that this is adding previous number and adding to that I, without tracing also, quickly you can do it. All right. Now, two more questions are there. Then we'll start next topic. Two more recursive function questions with just with recursion or static variables like this. Okay, no pointers, no arrays, no other operators. Watch here. See, you better wait for a while. I write the question because I am reading out and explaining and writing the question. So after that, quickly you can copy and start solving it. So listen this one. See, vo- uh, void get integer n, and if n is less than 1, do nothing, just return nothing. Return means simply stop. N is less than 1, just stop. Otherwise, get means call itself by n minus 1 and also call itself by n minus 3. Then after that, print percentile d value of n. So this is which type of recursion? Tree recursion, calling itself two times. Now, interesting thing. If you call get 6, if you call get 6, you don't have to show what is printed. You don't have to show what is printed. When you call get 6, you have to count how many calls it will make, including the first call. Total how many calls it will make. Get. Total how many times the calling is done. Now, question is not to show what is printed. Okay. You have to count the calls. Understood this one? So you have to start from get 6. So it's calling. If it is less than 1, nothing is happening, right? Less than 1 means up to 0 also it's calling, right? Less than 1 it's not calling further. For 0 also it's calling. So it will be keep on calling. Tree recursion tree you have to draw and then give the answer. All right. So like previous one was difficult. So this is also difficult. Then two more little difficult questions. Difficult means till now the things were very easy, but here you have to struggle a little bit or be careful. That's how it's difficult. Total how many calls it will make, you have to find out that. After this, two more questions. Sorry. One more similar, then one more with, two more are there with nested recursion. I'll show two more. To 1, it will work. For 0, it will not work. Sorry. Less than 0 means, less than 1 means when 0, it doesn't call itself further. Gupta, your question is, in the previous question, both will have their own variable I. Yes, separately. Separately. They are their own local variables. Means actually they are visible only inside the function. Yes, they are different variable. They will not use the same variable. It was having its own I in that every time the present value of n was added to it. And this one, the result of the function was added to it. So if you observe the pattern, then without tracing, means in detail, you can do it. Oh, you are using same I. No, no. You have to use different I. The name is same, but they are in different functions. How many? 25. Acha. Check, is there any faster way of doing it instead of drawing the entire tree? Because if you start get for 6, so much big tree I have to draw. So this is giving the idea that it will take so much time. So there should be some shortcut for this one. What is the smallest value for which this function works? Then if for smallest value for this function works means what? It will make calls. 1. If you say get 1, then 1 is n is less than 1. No, it is equal to 1. So it's not true. So enter inside. It will call get of, I will just write g here. Get of n minus 1, that is 0. And get of n minus 3, what is that? Minus 2. Will it call further? Will it call further? No. So it cannot call, it will not call further. So this is one call, this is one call, this is one call. So total, when you say get 1, there are total 3 calls. Total 3 calls. If you pass 1, there are total 3 calls. Now, if you say get 2, then what? 2 is not less than 1, then it will make call 2 minus 1. Okay, get off 1. And 2 minus 3, get off minus 1. Okay. Now in this is one call. Minus 1, will it call further? No. This is one call. Get off 1, do you already know the answer? What is that? 3. So total for this one, how much? 3, 4, 5 calls. Total 5 calls. If you pass 2, total 5 calls. Okay. Now, when you say get off 3, then what? One is get off 2, other one is get off 0. For get off 0, it doesn't call further. Then this is one call, and this is, sorry, this is 0. This is 0. This is one call. Get off 2, you already know the answer. So 5, 6, 7. So total how many calls? When you say get 3, total 7 calls. Under this, including this one, total 5 calls are there. This part and that part. You got the idea now? All right. So in this way, you can solve the question. See, how do you guess? How do you judge that? How you should solve it? See, the value itself is saying 2 times a tree call. See, I have shown you tree recursion last class. What was the value I was passing? I am asking you to print the result. 3. 3. Your answer was 3, 2, 1, 1, 2, 1, 1, something like this. If I say 6, then I can take a long break. You will be busy in drawing and getting the answer. So that itself is already, you saw that with the 3 you are getting a huge tree, with 6 it will be more bigger. Oh, already I know that this will be a very big tree, so there should be some shorter way. That's how you can go for shorter way. Okay, so the question is, answer is like earlier also when printing was done, too many values were there. So I said that if you try start printing, it will take a lot of time. So try to figure out from the answers itself, options itself. So can you get the answer further? Shall I do it further? Huh. Now when you say get 4, one time it will say get 3, another time it will say get 1, get 1. Now in this, if you see, this is 3 na, so 7 calls. This is 1 na, so 1 means including this one, total 3 calls. And this is 1 call. So 7, 8, 9, 10. So sorry, 10, 11, 11 total call. 7, 3, 10 plus 1. Total 11 calls are there. Now, if you say get 5, then this is get 4 and this is get 2. Get 2. 4 you already know 11 calls, 2 you already know 5 calls, and this call also just get 5, one more call, right? So 11 plus 5, 16, then this is total 17 calls. Now lastly, get 6. Get 6. So this is get 5 and get 3. Subtracted 3, right? So I remember the code now. So this is 5 is how much? 17. 3 is how much? We already know the answer, 7. And this one more call. So 17 plus 7, 24 plus 1, this is 25. So total 25, this is the answer. Okay. Now the next question, solution approach will be similar. Okay, solution approach is similar. Here, printing was not important. They asked the calls, number of calls. Why? They wanted to see whether you know how to solve this in pieces. Otherwise, for one question, you will be spending a lot of time. You'll be wasting your time. If you can do it in pieces, you can quickly do it. I was explaining, so I have taken time for it. One, two, three, four, five, six. Yes, 25 is the correct answer. Yes, some of you have done it. Very good. You can note down if you want. This will help you in the next question. Yes, yes, Varun, you have to consider them separately. Yes. Shall I go to next page? Over? Now, I will not help you in this one. This is similar, but there is a chance of giving wrong answer. This is similar. The chance of giving wrong answer means what? It's a hint that you should be careful. Integer x assign 1 and k. If n is equal to 1, return k. Oh, sorry. Return return x for k assign 1, k is less than n, plus plus k, and x inside this for loop, x assign x plus fun of k into fun of n minus k, and finally return x. Only this line inside for loop, plus plus k. Yeah. Then you have to find out what is the result of the function for 5. This is a numerical type question. Numerical type question. The approach for solving this one is similar to the previous one. We started with the smallest and we were able to answer the question happily, easily. If you trace it, then for loop, everything will confuse you. If you start from small value, instead of 5, you start from 1, you get the answer. That will give you the idea how to get it for 2, 3, 4. Quickly you can get it. If you observe, every time x is declared for every call and it is made as 1, starting from 1 every time. It's not static variable. From online students, can you answer this? What's the result? Yes, correct. Very good. Adija, yes, correct. If you got the answer 41, it's wrong. So what is the correct answer? Actually, you have not reached the answer. You should follow the same way. If 1 is passed, then what? 2 is passed, then what? Anybody tried? क्यों रुक क्यों गए? Ah, k assign 1 up to less than n. So first time k is 1, right? N is 1, n is 1. So k is 1, k less than 1. So only one time it will repeat. Hmm. Hmm. When if it is 2, so k is 1 as well as 2. 2 calls, multiplication will be done. Hmm. Okay. Okay. Huh. No, k is 2, then it will run for one time. K is, sorry, n is 1, then just return. Otherwise, T is 2, it will repeat for 1 time. 3, it will repeat for 2 times. Okay, let me do few steps. Maybe that will help you to solve it. If you find out f of fun of 1 means f of 1. If it is 1, then return x. So what's this answer? 1. 1. Now, if it is f of 2, then what? 2 means it's not equal to 1. Then k is assigned with 1 and k is less than n, less than 2. Yes. So how many times for loop will repeat? Only one time. In that, what it will do is only one time, and I will write down like this only. So x assign x plus x assign x plus fun of k is what? 1 multiplied by fun of n minus k. K is what? 1. Na? So 2 minus 1 is how much again? 1. So what are the values here? What are the values here? X is how much? 1 plus f1 already we know 1 into 1. So total how much this is? Come on. 1 plus 1 into 1, 2. So the result of this function is how much? 2. The result of this function was 1. Now one more step I'll show you. F of 3. F of 3. F of 3 loop will repeat for how many times? 2 times. So what is the steps? X assign x plus 2 times. X plus 1 time, x plus 1 time. So same thing, x will is 1. That I have written it only one time. 1 here. So what is this? F of 1 into 3 minus 1 is what? 2. Plus f of 2 into 3 minus 2 is what? 1. So what is the result of this one? X value is 1 plus f of 1 is how much? 1 into this is 2 plus this is 2 into 1. How much? 1 into 2 to 5. So the result is how much? 5. So this is 5. 1 plus 2 plus 5. Okay? Correct or wrong? Am I doing wrong? Huh? Understood till here? Now, without looking at this, without looking at the code, f of 4 is how much? X assign x plus x is 1 definitely. You can see that always it's becoming 1 initially. Huh? Tell me, f1 with f3, very good, plus f2 with f2 plus f3 with f1. Very good. Correct. Perfect. Perfect. So the answer is how much? This is 1 plus, this is 1 into how much? 5 plus this is 2 into 2 plus this is 5 into 1. 5 plus 5, 10 plus 4 plus 1. Answer is how much? 15. So this is 15. Last step you have to do now. Okay. This can be done only this way only. You cannot draw the tree for this one. You cannot draw this one. Yeah. Exactly. I'll do it 2 times. I'll do it 2 times. That's what I was waiting for. And somebody will point out, or you have got the doubt, but you agreed, okay, leave it. So, but he asked, I am explaining here. That's why I'm insisting every time. K is every time 1, K, X is every time 1. I am telling this one. So let us take this one. This is a little lengthy. This is enough for us to understand. X is 1. X is 1. Now for loop. For loop. Right? For loop. First time what? X assign x plus means 1 plus what? 1 into 2. 1 into 2. How much is the result? 3. So the value of x is how much? 3. One more time is what? 3 plus 2 into 1 is how much? 2. So total answer is 5. So the value of x is 5. So every time x will not be added. X will be first time 1. Then that value is added and it becomes new x. And that value is added, it becomes new x. So I'm putting them all together. All right. So what is the final answer? And last step, have you done it? F of 5, huh? Do it again. Do it again. F of 5. See, I was not expecting that you solve it, this one. Okay, even previous one also. When I said hard questions from that time, I have to explain, then you solve it now. The next time you can solve it easily. All right. So 3 or 4 questions. And one more question coming, even that also you can't solve it. So you have to learn from this one. So I have explained you and you got the learning. Now you can do it easily. Similar question, you can solve it. Yeah, 51 is the correct answer. Lokesh also got the answer correct. One plus this one plus this one. So 1 plus this one plus this one repeatedly added. So first time x was 1. Now new value of x plus new value of x plus new value. So instead of that, all of them I'm adding. So what is the answer for this one? 5. F of 5 is how much? X assign 1 plus 1 to 4. F of 1 into f of 4 plus f of 2 into f of 3 plus f of 3 into f of 2 plus f of 4 into f of 1, right? So you know the values here for all of them. This is 1 plus 1 into 15. This is 15. I'm directly writing the answer. This is 2 into 5, 10. This is 5 into 2, 10. Plus this is 15 into 1. So this is 15. So if you observe 15, 15, 10, 10 in between, this pattern you are getting, right? So answer is how much? This is 20 and this is 30, 50, total 1, 51. Answer is 51. This one, no, I didn't get you. Uh-huh. It will be very lengthy tree, na? Now, the question is when you should do this one. Because you see this code is having a loop, a function is called many times, and this is again a tree recursion. And if you draw a tree for 5, it will be a very big tree, and to solve it, it will be difficult. So that is the reason we started with the smallest value. And the previous question also we did the same thing. So if you start with a smaller value, the benefit that you are getting is for the larger value, you are able to use the previous value. This is possible or not? When I can know f of 4, if I know f of 3, in that case, we are doing it this way. In the static variable, we could not do that because you should follow the same steps. In printing, we cannot do that because you have to follow the same steps. But now we are able to do it when it is becoming lengthy. This is not possible for all the recursive function. See, every recursive function we have solved it in a different way. Sometimes just we read the code and gave the answer, right? So for every question, the trick is a little bit different. So this was learning. Now similar question when you see, you can identify it. It will click you. Yeah, I can do it directly like this. So you'll do it. Don't worry about that. Okay, question itself will tell you. But you have to practice all the things that you have done today. You should repeat them. Spend time and repeat it. And if you have question, just you can frankly ask the question. I'll explain you again. Okay. I may not answer then and there, but I will cover it once again as a part of a class. Okay. I will understand what your doubt is. I'll create it in some other way. But definitely I will answer your question. Don't hesitate at all, because you are going on under training or coaching. See, coaching means what? In sports also coaching is done, right? So take a round of the ground, take a complete round 10 times. One will run fast, one will run slow. But all has to run, then only they will go for the next step. You agree with this? So I am asking you to make a round. So don't just sit idle or stand there. You have to run. You have to run. All right. So this practice is very important. Every question, the pattern is like this only. I'll be giving the question, you will be solving it. Then whatever the doubts you have in that, I will clear it. Is it okay? Are you comfortable with this? Are you enjoying this approach? Now the next question. This is a very old gate question. Yesterday we saw that there is something called as nested recursion also, and this is an example of nested recursion. It's a gate question, and it's a very old question. It was written using some other language, but I am writing it using C language. I am modifying it. I am modifying it. If x is greater, syntax I am using C language, and you will give a wrong answer. Then I'll explain you what is the correct method of solving this one. Fun of x plus 11. What will be the result if you call this function by passing 95? Now, one hint to get the correct answer. See, this is a nested function call. Follow this. 95 is passed. 95 is not greater than 100. So it will come here. Function of 95 plus 11. How much? 106. So what is the result of function of 106? 96. So this become function of the result of this one. He got it as 96. 96. Yeah. Understood this one? So 95 is passed. 95 is, read it. Follow this one. I'm showing you. I'm not tracing directly. I'm showing here. 95 is greater than 100. No. So function of 95 plus 11. 95 plus 11 is 106. So now you forget everything and say fun of 106. Fun of 106, how much? 106 is greater than 100. So return what? 96. So the result of this one is 96. So now read what it is. Fun of 9. So you have to call fun of 96 once again. So this portion you should do it separately. Now, if you understand the pattern, just you can go on doing it quickly. I have explained you sufficient. Solve this one. So it is nested. You should do it 2 times. This is an old question. Now, new question is also there with nested recursion that I will show you next. Fun of 95. This will become what? Fun of 106. Now, what is fun of 106? Fun of 106 is, oh, 106 is 96. So this will be replaced with 96. Then fun of 96 is how much? Oh, sorry. Fun of 96 is how much? Fun of 107. Then fun of 107 is how much? 97. So this value is how much? The result of this is 97. So this is fun of 97. Fun of 97 is how much? Fun of 98. And oh, sorry, yeah, right. Fun of 108. Then what is fun of 108? Fun of 108, if it is greater than 100, just minus 10 and return it. So this is 98. So the result of this is how much? 98. So then this is nothing but fun of 98. So fun of 98 is how much? Fun of 109. 109, oh, sorry, 109. So now this result is how much? 99. So directly I'm writing now fun of 110. So this result is how much? 100. 100 is not greater than 100. So continue. Fun of 110 is how much? 100. So then again fun of what? 111. Then fun of 111 is how much? This is 101. Then fun of 101 is how much? 91. So no further calling, because both the times it was greater than 100. So return 101, then this call return 91. So go back to this 91, 91, 91, 91, 91. All the functions will return 91. See, call. Last one got the result as 91. So it will pass to the previous call. It will take that and pass to the previous call. So same value will move up. 91, 91. Answer is 91. Understood this one? All right. Last. Int bar int bar int n, if n is equal to 1, return 0. Read bar this function thoroughly, else return 1 plus bar of n by 2. See, can you tell me what this function will return? If you pass anything, what it will return? If you pass 8. If you pass 8, read it and tell me what it will return. 8. 1 plus 4. 1 plus 2. 1 plus 1. For 1, it is 0. So 0. Fun of bar of 1 is, sorry, 0. So 0 plus 1 plus 1 plus 1. So how many times 1 is added? 3 times. So for 8, it is 3. 3. For 8, it is 3. For 16, so actually it is giving log n, not power, log n. Yeah, log n you can say. The exponent it is giving. So in inverse of that, we call it as log n. So it's giving log n. Okay, understood this one? Now I am writing another function. Watch here carefully. And this is a numerical question, and it is from 2020, yeah, 2026. Latest question, numerical question. All right, watch here. Next function. So just you read it, then you start copying, and then you solve it. That's the reason I am writing it. Otherwise, I should have shown you the PDF every time. So when I am writing, I am explaining also. A function foo which takes parameter n, and if n is equal to 1, return 1, else return 1 plus foo of bar of n. This is the question. Code I have written, right? So when n is 1, return 0. When n is 1, return 1. And this is nested call, right? Nested. So not nested recursive, but nested call. Function is calling another function. So result of this function is taken by this foo. All right. So pass 16 and tell me what is the answer. For foo of 16, tell me what is the answer. This is not exact gate question. I am making it simple. Just asking you to find out what is f of. I am asking you what is f of 16. Then we'll see what is exact gate question, what they have asked. Four, right? Four. For eight, you have the answer if you have traced it. For 16, answer is 4. For foo of 8, answer is 3, right? 3. If you have already got it, all of you got it, then I'll give the exact gate question. Shall I trace it or you got the answer? 4 and 3, you got the answer, right? Now the question is coming, actual gate question. For what value of n, you will get the answer 5. Log of 16 is, right, 4. Log of 8 is 3. So every time it's doing log, right? Log of, like that it is working, right? So It's taking logs. Actually, when you gave 16, what's the next function call you got? 4, not 8. You got 4. So what is 4? Log of 16. The next you got 2. That was log of whose log is 16. Then only you can get the previous value, one more value extra. Got the idea? It's not 32, it's not double. Whose log is 16? Understood the question? The question is, for what value of n, the result of this function will be 5? That's the question. Now, you have to scratch your head. So for that, try. You understood what is happening here. So you can try 16 and you see what is happening 4. Then for what you will get 5, not for 32. You put 32 and see what the answer you will get. Try to put 32 there and see whether you get 5. Still you get 4. You put 32 there and see. So you'll realize, oh no, it's not 32. Solving, huh? Solve. नहीं. Huh? See, for 16 you got 4 now. Acha, you are telling this answer. No, no, no. I thought you are answering for 32. For 32, how much you got? 4 only, na? Anybody tried? 2 power 16 is 65536. Log of 65536 is 16. So for what value of n you get the answer? 16 is 65535. So foo of, okay, it will be like this. Foo of 65536. Next call will be foo of 16. Next call will be foo of log of 16 is how much? Log base 2 is how much? 4. Next call will be foo of 2. And the next call will be foo of 1. 1, 2, 3, 4, 5. It's like this. 6, 2 power 16, first class we learn, we know that, right? And log is the inverse, that also you know that. The quick answer you got 32, right? So that was wrong answer. Why it is wrong answer? See, this function is giving log of logs, right? Every time it is giving log, right? It's log. So when you say 16, its log is 4, then it's log. So what should be there above so that you get log as 16? Whose log is 16? 6553536 log is 16. You agree with this or not? Uh, uh. So how you got that idea? Put 32 and see. You will get 4 only. You will not get 5. You will not get 5. So don't give the quick answer 32. Okay. So 64. So then you slowly go, okay, that is, it should log of something whose result is 16. Log of n is equals to 16. So what is n? What is n? N is equals to 2 power 16. So n is how much? 65536. Simple. Other way. The other way I have shown. So that's it. This was still a learning part. Okay. So I was not expecting that you will give the correct answer for this one. Initial questions, you have given correct answers, right? Then later on, whenever there was some trick involved or some new concept was there behind, I was supposed to explain it. So you have learned them now. All right. So like recursion, when you are able to solve it, because you have attended previous class, then only you are able to solve recursion. So this one you cannot solve unless you have some idea. So I have given you the idea behind it. It was simple recursion only, but little bit idea was required. So in this way, in every question you will have something behind it. So you have to follow that one. Now, one important thing. On what key point this question was designed? Log. Log. Yesterday in the recursion examples also I have used log. And one more previous question you saw, you have seen similar log. By two, you have seen it many times. So on that basis only they have designed the question. Did you find any similarity in between the questions, gate questions? Yes, some key points are there. So that key points are important. Okay. So for remembering all these, you must revise all these questions. Keep on looking at them. Look at the question. Oh, if you are able to solve it in your mind, it's very good. Otherwise, trace it. Trace it. So first time you trace it. So anyway, we have to start the next topic, that is pointers. We will start tomorrow. Pointers we will start. That's going to be a fresh topic. I'll explain the syntax. I'll explain you everything about the pointer. Then we will see the questions using the pointer. All right. So the concepts, then we'll see all the questions. So that's all for today. Gupta,